Hi, my name is Ola.
And I'm Jarek. Greetings from Warsaw.
We are DevOps engineers and we help developers in optimizing build and deployment processes on different environments, mostly Kubernetes.
We would like to tell you about two great pieces of technology, namely Network Service Mesh and the Tungsten Fabric Virtual Network Controller, and how to make them work together to form a nice multi-cloud setup. If you have ever deployed an application in a Kubernetes environment, there is a high chance that you encountered some problems when trying to connect to the outside world. Everything works perfectly as long as all your dependencies are contained inside a single Kubernetes cluster. But when you start to integrate with some external services, you need to deal with stuff like routers, firewalls, security policies, and different VPN applications that don't really fit into the cloud-native automation provided by Kubernetes. And they actually shouldn't be a concern for your application.
Network Service Mesh is a tool that aims to solve this exact cloud-native networking problem and be a game changer in this field. It brings cloud-native to the networking world by exposing an API that allows you to dynamically create and attach your workloads to services inside and outside of your deployment environment. And Tungsten Fabric appears to be a great complementary technology for Network Service Mesh, and we would like to show you why.
So, here comes the agenda for today.
We will start with a brief introduction about Network Service Mesh, so what it is and what architecture it has. Then we'll explain on a high level how the connectivity between a pod and external world can be established with NSM.
Then we'll say a few words about what is Tungsten Fabric, and we'll give an overview of the implementation of a Tungsten Fabric forwarder for NSM, which we've prepared for this presentation. At the end, we'll give a demo of Tungsten Fabric forwarder with OpenStack cluster and Kubernetes cluster.
Okay, so let's start with a question. What is Network Service Mesh? So Network Service Mesh is CNCF standalone project that extends networking solutions implemented in Kubernetes. And it provides L2 and L3 networking for applications deployed in Kubernetes and facilitates the configuration of connectivity between a pod and external services, for example, pods from different clusters. Basically, you can think of it as a way to dynamically attach additional network interface to a pod. Let's take a look at a few Network Service Mesh components relevant for this presentation. So, Network Service Registry, it's here, and it contains all the available virtual networks. In this case, it's Alice and Bob. Network Service Manager, it is a control plane component. It is a daemon set deployed on each node in a cluster. It accepts network service requests from pods, verifies network service presence in Network Service Registry, and forwards the request to the forwarder. And Network Service Mesh Forwarders. So forwarder is a Dataplane component. It provides the connectivity requested by the manager, and this is a pluggable component. So official Network Service Mesh code repository provides implementation for VPP and kernel. But we want to show you how the new implementation can be done on Tungsten Fabric example. So let's talk now about how Network Service Mesh is used to establish connectivity between a Kubernetes pod and an external service. So we have a Kubernetes node with a pod A inside. And how can we connect with an external network from the pod? So first, we need to install Network Service Mesh in a cluster. So this part. And it will provide Network Service Manager and forwarder modules. And Network Service Manager maintains a list of available forwarders and network services. And it's called Network Service Registry. And in this example, we have two forwarders here and two networks already registered. So what happens next? Pod A creates network service request to Network Service Manager to attach to a new service, to a new network service. In request, it specifies to which service it wants to be connected to and which mechanism should be used with which forwarder. So it wants to be connected to Alice, and it wants to use VPP forwarder in this case. And this request can be sent whenever application needs to connect to the network. So yeah, now manager takes over, and manager verifies if Alice network is available in the registry. So yes, it is available. The response, positive response, goes back, and now network service manager forwards the request to the forwarder, to the VPP forwarder, because this is what pod A requested. And the forwarder adds an interface to pod A and enables connectivity to Alice network. And that's it. We have pod A connected to the external service through newly created network interface. But of course, default Kubernetes pod network is still available. So this is how network service mesh works, and each forwarder has its own mechanism for providing connectivity to the services. Today we want to show you how Tungsten Fabric can be used as such mechanism. So to do so, we've prepared our own forwarder, which we'll present later on, but let's talk about Tungsten Fabric first. So what is Tungsten Fabric? Tungsten Fabric is networking backend for Kubernetes, OpenStack, and for public clouds. For example, it allows to create virtual networks, to provide connectivity between virtual machines on OpenStack and pods on Kubernetes. And in the demo, we will show interoperability between Kubernetes and OpenStack, but the same approach can be used to connect pods to any other environment supported by Tungsten Fabric. So it gives you an opportunity to create multi-cloud architectures. So on the slide, we have an example of Tungsten Fabric installed on OpenStack environment, and Tungsten Fabric is the main network provider in this cluster. So Tungsten Fabric connects virtual machines in private networks. It provides overlay networking. In the picture, you have 4 virtual machines on 2 OpenStack hosts with Tungsten Fabric vRouters installed within. And Tungsten Fabric maintains a global routing table and keeps it synchronized between the vRouters. So now we'd like to connect this word to a Kubernetes cluster. So here comes network service mesh forwarder for Tungsten Fabric. So first, let's get back to the setup of Kubernetes cluster with network service mesh already installed. And let's add the Tungsten Fabric cluster to the picture. So what we need to do is to install 2 new components, Tungsten Fabric vRouter and Tungsten Fabric forwarder for network service mesh. So that vRouter is Dataplane component. It is responsible for packet tunneling to other vRouters. And the forwarder is control plane, and it carries out stitching the pod together with the vRouter. Okay, so again, pod A wants to connect to the network. So it creates a request to Network Service Manager to attach to a network. But this time it says it wants to use Tungsten Fabric forwarder, and it still wants to connect to Alice network. Okay, so Network Service Manager takes over, and it asks the Network Service Registry, is Alice there? And yes, it is. So response goes back, and now Tungsten Fabric forwarder takes over. So Tungsten Fabric forwarder links pod A to Alice network by adding an interface to a pod. An interface is plugged into vRouter. An entry is added to the Tungsten Fabric routing table with a new IP address associated with Kubernetes node. And in result, we have configuration set up in vRouter and virtual network routing table. And that enables pod A to have two-way communication with virtual hosts in the Tungsten Fabric network. So now, Tungsten Fabric controller ensures that all the vRouters have a consistent view of the network. All the routing table entries are continuously synchronized among all the hosts. So that So in this way, virtual machines can talk to the pod and vice versa. Our example covers connectivity to OpenStack, but it's not the only cloud computing platform supported. So yeah, that's it. That's it when it comes to the theory. But now I'm giving the floor to Jarek, who will show you how it works in practice.
Okay, thanks and welcome back. I will now show you a short demo of the integration between a Kubernetes cluster and an OpenStack cluster. I will connect a pod to network, L3 network with virtual machines using a network service mesh and a Tungsten Fabric virtual network controller. So let's start with our environment. We have a plain empty OpenStack cluster over here. We view it using the graphical interface Horizon, and we also have a working Kubernetes cluster with the NSM installation already provisioned. And we can see the network service manager and the network service mesh Tungsten Fabric forwarder already registered over here. So we can use it to service network service mesh ware applications. Okay, and we also have our Dataplane, which will be the Tungsten Fabric virtual network controller. And Tungsten Fabric is already connected to the OpenStack cluster as a Neutron plugin. So it's servicing all the interfaces, all the network interfaces for virtual machines in the cluster. However, it's not configured as a CNI for Kubernetes. And it's just to show you that you don't need, you may use it as a CNI because it has the feature, but you don't have to use it as a CNI. So you can use a totally different CNI in your Kubernetes cluster and at the same time use TF as a networking backend, as a data plane backend for network service mesh to achieve the connectivity for the multi-cloud architecture. Okay, so right now we don't have any networking configured in our environment. So let's start with creating our infrastructure on the OpenStack side. And I will create two networks, red and blue, to demonstrate the connectivity and to show you that we can use different networks and choose them using network service mesh requests. So we'll create first a red subnet with a 10.1.1 addresses, and then a blue network with a subnet of 10.2.2.0. Okay, and with both networks configured, we can see that Tungsten Fabric is synchronized with the OpenStack cluster, and it already shows the networks with proper configuration. And let's go ahead and create two virtual machines in the red network. This will be our first experiment. Okay, we are choosing the red network, so we want the virtual machines to be attached to the red network. Okay, they are running. And on the Tungsten Fabric side, we should see the interfaces attached to the virtual router. Okay, here we can see the two interfaces in the red network, 1.3 and 1.4. And just for the sake of this presentation, just for the purpose of this presentation, we will use virtual router internal interface to connect to them. So SSH, okay, go cubs go, and we are in, and we can see that we are on the first virtual machine, 1.3, and from here we can SSH to 10.1.1.4. Okay, and this is 1.4 virtual machine. And going back, there's two-way connectivity, so I did it just to check if everything's working okay. And it's obvious that the OpenStack virtual machines in the same network can communicate with each other. Okay, so now it's time for the network service mesh pod. I will use pod manifests that are located over here, and they are adapted from the official network service mesh examples. And here you can see a pod with a BusyBox container inside the deployment with an annotation, network service mesh, IO, and the what's called the fully qualified name of the network inside the Tungsten Fabric database. So we have a default domain, the project name, which is admin, and then the network name. So let's create this pod, this deployment, apply red deployment. Okay. Now let's see what's happening inside our namespace. The red pod is initializing, and you can see that there is something unexpected going over here, because we see that it's running some init containers, while our original deployment has got just only a single main container, and I will explain this in a minute. But for now, it's already running, so we can see what's inside. And okay, and we can see that we have two interfaces. First one is the default pod network, cluster pod network. This is the default interface, and then we have interface with a random name, which is a member of the red network. And we can see if we are able to connect to the virtual machines on OpenStack. And yes, both 3 and 4 are reachable from our pod. So the Tungsten Fabric forwarder successfully bridged us to the red network on OpenStack. Okay, and now let's explain how it all happened. As you can see here, we have a network service mesh admission webhook pod over here, and it's a piece of NSM that is listening to all the objects that are onboarded into the namespace, and if it detects network service mesh annotation, it will modify the pod manifest, and it will add sidecar containers that will configure the appropriate interface, and they will handle the communication with the NSM API. So let's see how the modified specification of the red pod looks like. Okay, so we have the container, the base container that we've seen inside the original manifest, and then we have additional NSM monitor container. And then the important part, init containers, DNS init container and the NSM init container. And the NSM init container is responsible for talking to the network service mesh API and creating the interface according to this network service request. And in our case, the network service is the network itself. So we are requesting connectivity. We are requesting to be joined to this particular Tungsten Fabric network. Okay, so you can see that there is a pretty nice separation of concerns in the application manifest. The application is just this part, like it's a regular application that is totally unaware of any NSM machinery, right? And while using the deployment, while creating the deployment, we are adding a network service mesh annotation that tells the orchestrator to connect us to some specific network. So we have nice layers. So we have the application running on a cluster that is equipped with NSM, and by modifying metadata of the application, we are making it a part of some network environments. So I think that this is a really nice way, a really nice cloud native way of specifying which network connectivity our applications should receive on the target deployment. Okay, and to see that the Tungsten Fabric forwarder is flexible, I will now create third instance in the Blue network, a Blue demo network with the same configuration except for the network. It's creating. Let's wait for it. In the Tungsten Fabric interface, we can see. Okay, and create the Blue pod. Okay, this is going through the same sequence that the red pod. Okay, it's finished. And let's go inside and see that we have 10.2.2.4 interface. So we are inside the Blue network, and we can, in the same way, see the interface in a Blue network on the Tungsten Fabric side. Okay. So this is it for this part. We created the Tungsten Fabric forwarder as a POC. So it has the basic functionality of creating interfaces and hooking them up to the vRouter. There's much more to do, but I think that it's a nice way to first show you how the Tungsten Fabric is a nice fit to the network service mesh and its philosophy of cloud native network connectivity. And one of the nice appealing features of Tungsten Fabric is also that it is able to connect different workloads into service chains. So for example, cloud native network functions running as pods on Kubernetes with virtual network functions running as instances on OpenStack, for example, and physical network functions and physical appliances, because it is able to bridge them to overlay networks with switches that are VXLAN capable. And the second part is that our source code may serve as an example for other forwarders and for other people that want to customize the network service mesh and add their own functionality or add their own Dataplane support. So you can go ahead and see the code in our repo. And I also would like to mention that this idea was inspired by Radoslaw's talk at the Open Networking Summit Europe last year, when he talked about his kernel forwarder, which was also meant as a similar thing to inspire other people to write their own plugins for the network service mesh. Okay, I hope that you liked our idea and our talk, and it's now a time for the QA part. Thanks.